Welcome to this learning video on Industrial Electrician by Power Sector Skill Council, produced in collaboration with SEMCA. This video is aligned with the job role Industrial Electrician PSS/Q1705, NOS code PSS/N1707. We are going to learn the step-by-step procedure to perform industrial wiring as per specifications. Introduction of industrial wiring. Industrial wiring is based on three-phase electrical power. A three-phase electric power allows fewer amperes on each wire, while giving the same power output in HP/kilowatt. It helps in reducing the power losses in system and save money. In three-phase electricity, the wires are smaller and the motor is smaller than a single-phase motor. No matter which type of three-phase electrical power chosen, we will need a voltage meter to determine the actual voltages that are available. In industrial wiring, unarmored cables run through metal conduits, cable trays, or a raceway. Armored cables can be directly buried in ground or put in trenches. Now you can see three-phase distribution panel, from where we have given power supply to motor through direct online starter DOL. In a single-phase connection, three wires come into electrical service panel. A blue or red or yellow live wire, a black neutral wire, a green earth wire. A voltage difference of 230 volt separates these two wires. In a three-phase connection, 4 or 5 wires come into electrical service panel. As you are seeing Electrician with the available installation, 3 live wires, red, yellow, blue, a black neutral wire, a green earth wire or appropriate size GI wire or GI earth strip. Here we have used GI wire for panel body earthing purpose. Most of the time, a voltage difference of 230 volts separates each live wire from the neutral, while there is a voltage difference of around 400 volt between two live wires. Install single-phase and three-phase electrical power supplies. To operate high-power equipment such as electric motors and high-power rated air compressors and so on, we need three-phase power supply. Large motors take a lot of current during starting. This current could be 6-7 times of the normal current of the motor. Please read data plate for amperes and other details of motor. High starting current can cause problems like voltage drops and overloads of cables. For large motors above 3 HP, we certainly need a motor starter to control the starting current. We use DOL starter for medium-sized motors and star delta starter for large motors. In large industries, we use MCC, Motor Control Center, which is used to control many motors from one place. Within MCC panels, you will see voltmeter voltage measurement, ammeter current measurement, indication lamps on-off, trip indication, MCCB molded case circuit breaker, etc. In large industries, you will also see APFC automatic power factor correction panels. These have capacitor banks inside, which help in improving the power factor and reducing the system current. In homes, we mostly use single-phase power supply to operate lighting load, fans, washing machines, etc. But in some cases, like multi-storied and large buildings, three-phase power supply is needed to operate and maintain the system. Here you are seeing motor starter panel, which used direct online starter. Incoming three-phase supply connected at 4-pole molded case circuit breaker, MCCB incomer terminal. MCCB having rotary handle for on-off operation. As you are seeing operating rotary handle, knob is fixed at the door. Also we have used 3-pole MCB and 2-pole MCB contactor and timer. Now we will see how to connect cable at the MCCB input terminal and earthing at the panel body terminal. You are seeing we have already connected the lug in the cable. Now before connection through digital multimeter, we will ensure that there is no any power supply at the connection end. Our technician check and find 0 voltage, which is showing there is no any supply voltage. Now we can connect the cable at the MCCB input terminal through proper nut and bolt and torque wrench ensure proper tightness at the terminal. Now cable termination at the MCCB input terminal completed. Now we will connect the GI earthing wire at the panel body. Technician already connected the lug at the GI wire. Now through the spanner ensure proper tightness at the panel body earthing point. Now panel body earthing as well as input power supply at the panel connected. Now panel is ready to charge. In order to assemble different termination adapters, we use cable gland at the cable entry into the panels and use lugs or thimbles for final termination on equipment or bus bar. This is used in conjunction with cable and wiring for electrical, instrumentation and control, and automation systems, including lighting, power, etc. Now we will see the procedure of cable glanding. Our cable size is 3.5 core, 25 square millimeter, for which we are using gland of 28 millimeter in size. For fixing gland at panel base plate, we have made 28 millimeter size hole through hole saw cutter. We are measuring the cable from the base plate to the termination point with some extra margin. Now we are removing the outer and inner insulation sheet and armor of the cable. Now we will fix the gland. First we are putting compression nut. Now we inserted gland body. Now inserting clamping ring. Now inserting armor clamping cone. The armor cone part will be at the cable armor. Therefore, as per armor cone size, we are measuring the length of armor and accordingly, we are removing the outer sheet of the armor for fixing the armor's clamping cone at the armor. Now we have placed a gland armor clamping cone at the cable armor. Now we are inserting the nipple entry part. Now we are connecting each part and ensuring proper tightness with the help of a monkey plier. Now finally we are tightening the compression nut with the use of a monkey plier. Now we are inserting the cable in the panel through a base plate hole made for the gland. Now we are inserting the final check nut of the gland which will tighten properly with the panel gland plate. By this way our cable glanding completed. The main functions of the cable gland are to act as sealing and terminating devices. To ensure the protection of electrical equipment and enclosures, including the provision of environmental protection, the main functions are earth continuity. In the case of armored cables, when the cable gland has a metallic construction, in this case, cable glands may be tested to ensure that they can withstand an appropriate peak short circuit fault current. Holding force, to ensure adequate levels of mechanical cable pullout resistance. Additional sealing, on the part of the cable entering the enclosure when a high degree of ingress protection is required. Additional environmental sealing, at the cable entry point, maintaining the ingress protection rating of the enclosure with a selection of applicable accessories. Cable glands can be constructed from metallic or non-metallic materials or a combination of both. This may also be resistant to corrosion as determined by selection to a standard or by corrosion resistance tests. Now we will see busbar system. Busbar trunking is generally applied to distribute the power over a predetermined area. Busbar trunking can be run vertically or horizontally or a combination of both. Typical applications of busbar systems are following. To supply to large number of light fittings and other outlets. To provide power distribution around factories and offices. Main busbar that distributes power horizontally between the various switchboard columns. It may be installed on the top, middle or bottom of the switchboard depending on the type of switchboard, customer specifications and/or local practices. You can see incoming cable connected at air circuit breaker input terminal through busbar. Output supply of the air circuit breaker connected at busbar. Through busbar power supply distribution happens at the different feeders. Here busbar running at the top of the panel. Now we will see the factor to be considered for busbar design. The following must be taken into account when choosing a power busbar. Current rating, conditional short circuit current, rated short time withstand current, environmental characteristics of the switchboard, ambient temperature, IP degree of protection, pollution. Here our incomer air circuit breaker rating is 800 ampere. Therefore the busbar rating should be at least 800 ampere. Here we have considered rated short circuit current 50 kiloampere, which is as per our system fault level. We have to consider the factor of ambient temperature, IP degree of protection. The installation of a power bus bar consists of the following steps. Select the material, copper or aluminium. Install it in compliance with the creepage and clearance distances of the standard. We can select material of bus bar as per our requirement, that is, copper or aluminium. Here we have selected the tinned copper bus bar, tinning one layer on the copper bus bar which protects from corrosion. Copper density in the bus bar should not be more than 160 ampere per square centimeter or 1.6 ampere per square millimeter. You're seeing the bus bar marked with red, yellow and blue color marked for phase and black color marked for a neutral color. Here in each phase, we use two numbers 75 mm width, 5 mm thickness size bus bar. In the neutral, we have used a 50 mm width, 5 mm thickness size bus bar. Install the bus bars bare or insulated in such a way as to eliminate all risk of short circuits, in particular by complying with clearances, creepage distances, the number of supports to install, the rules for securing these supports. As per defined standards, it is required to have applicable clearances inside a switchboard. These requirements are based on the principles of IEC 60664-1 standard and enable the coordination of clearance inside the switchboard. Clearance is the shortest distance in the air between two live conductors, between a live conductor and the ground. Here face-to-face distance between bus bar is 25 mm. Phase to neutral is 19 mm. Creepage distance here we have maintained 25 mm. Bus bar with the panel to be fixed properly with insulator support as you are seeing. The standard provides a table giving the minimum clearance to comply within order to observe the rated impulse withstand voltage declared by the manufacturer for a circuit. Rated impulse withstand minimum clearance ampere voltage kilovolt per rated millimeter. Less than 2.5, 1.5, 4, 3, 6.5, 5.5, 8, 8, 12, 14.